Now we are going to discuss the pressure at a point which was first understood by Blasius Pascal, who lived during this period 1623 to 1662. According to Pascal's, pressure at a point in static condition is same in all the direction. This is the Pascal's statement. Now to understand this further, we will do a small analysis to prove this, that pressure in a static equilibrium condition is same in all the direction. We have this figure. Now look at this figure. In this figure, we have a liquid filled up to this level. So this level is known as a free surface. For this liquid, which is in static equilibrium condition, we will take a vase-shaped fluid mass. We will take a vase-shaped fluid mass from this equilibrium condition, and this vase-shaped fluid element is enlarged here. This vase-shaped fluid element is enlarged here. Now when we have separated the vase-shaped fluid element, then we have to draw the free body diagram, and to draw the free body diagram, we have to apply all the forces coming on this vase-shaped fluid element separated from the main fluid. And this vase-shaped fluid element is subjected to mainly two type of forces. One is known as surface force and another one is known as a body force. Surface forces are those forces which acts on the surfaces, like pressure force is one kind of surface force, and body forces are those forces which are proportional to mass of the fluid element, like gravitational force is one kind of body force, acceleration force is also one kind of body force. So we will develop and draw all the forces being applied by the surroundings on this vase-shaped fluid element in the form of surface force or body force. So on this vase-shaped fluid element, this shape is separated, this face is separated, and on this face we have pressure force multiplied by corresponding area for this coordinate system x, y and z. The elements is having shape and size which is shown here. This distance is delta x, this distance is delta z, and this distance is delta y. So what is the force acting on this side in the direction of x is equal to force. What is force? Force is equal to pressure. Pressure is designated as Py, Py multiplied by delta x, delta z. This is the force acting in this direction. Similarly, another body force from the bottom face, it is acting upward, because pressure always acts in such a manner so that it compresses the fluids. With the help of this statement, we can show the arrow of the pressure, that pressure force should be applied in such a manner so that it will compress the fluid. What is the pressure in this direction? It is designated as Pz. Pz multiplied by corresponding area of the face, that face is having area, this distance multiplied by this distance. So keeping that figure in mind, we have equated, this is a force in y direction, this one is the force acting on s direction, it has component in y direction. So with the help of trigonometry we can resolve the forces and we can find out the force in y direction, and this force is equal to mass into acceleration. Now when we are using this acceleration, under that condition also fluid may be in a static equilibrium condition. Like, to understand it, let us take one example. If we have a container and that container is not moving with reference to the observer which is standing on the road, so in that case this fluid is in static equilibrium condition. Now if this container is on some train and that train is moving, then with reference to observer this container is moving, but with reference to container wall this fluid is in static equilibrium condition, and this fluid will be subjected to normal force at the faces, and it will not be subjected to any tangential force, and if it is not subjected to any tangential force it will be in static equilibrium condition, because we know that fluid can't resist shear stress. Under the application of shear stress fluid starts moving. So, we may have both situations, whether acceleration is 0 and whether we have some acceleration. In both cases we may have static fluid. So, this force is equated as mass into acceleration. Similarly, in z direction also this force in s direction is resolved in z direction, and we got this relationship. Now, with the help of this simple concept of trigonometry, this distance delta s can be written in the form of delta z and delta y. What is delta s? This angle is theta. So, delta s cos of theta is equal to delta y, and delta s sin of theta is equal to delta z. So, with the help of this trigonometry concept we can write delta s in the form of delta y and delta z with the help of theta. So, by incorporating this concept and further solving it, we get this equation P y minus P s is equal to rho a y delta y divided by 2, and similarly in the z direction it is P z minus P s is equal to rho a z plus gamma into delta z over 2. So, after doing some algebraic manipulation we reach to these equation, and if we have a point then delta z and delta y tends to 0. In that case this will become 0 and this will also become 0, and we can say that P y is equal to P s and P z is equal to P s. Now, similarly after reorienting this figure we can prove P x is equal to P s. So, now we can say that pressure at a point is same in all the direction, that is P s direction, s direction, y direction, z direction and x direction. So, with the help of this small explanation we can prove that pressure is same in all the direction at a point in static fluid, which is known as Pascal's law.